Electrical machinery 1 DC generator, compensating winding and commutation. First, we discuss about compensating windings. These are used for large direct current machines which are subjected to large fluctuations in load, that is, rolling mill motors and turbo generators, etc. Their function is to neutralize the cross magnetizing effect of armature reaction. In the absence of compensating windings, the flux will be suddenly shifting backward and forward with every change in load. This shifting of flux will statically induce EMF in the armature coils. It may be so high as to strike an arc between the consecutive commutator segments across the top of the mica sheets, separating them. This may further develop into a flashover around the whole commutator, thereby shifting circuiting the whole commutator. These windings are embedded in slots in the pole shoe and are connected in series with the armature in such a way that the current in them flows in opposite direction to that flowing in armature conductors. Directly below the pole shoes, figure shown compensating winding and generators. That is NNS black pairs or main poles, NNS and brown colors enter poles. The brown lines are compensating winding shown in figure. Compensating winding circuit diagram shown in figure. That is, compensating winding are connected in series with generator armature. Disadvantage: high cost, violent fluctuations in load. DC generator, compensating winding, number of compensating winding, number of armature connectors per pole is equal to Z divided by P. Number of armature turns per pole is Z divided by 2P. Number of armature turns immediately under one pole is equal to 0.7 and Z divided by 2P. Number of armature turns per pole for compensating winding is equal to 0.7 and Z divided by 2P. Number of armature ampere turns per pole for compensating winding 0.7 and armature ampere turns per pole. Commutation. Commutation process is currents induced in armature conductors of a DC generator or alternating. To make the flow unidirectional in the external circuit, we need a commutator. Currents flow in one direction when armature conductors are under N pole and in the opposite direction when they are under S pole. As conductors pass out of the influence of a N pole and enter that of a S pole, the currents in them is reverse. This reversal of current takes place along magnetic neutralizers or brush traces, that is, in the brush pans, and hence short circuits that particular coil undergoing reversal of current through it. The process by which current in the short circuited armature coil is reversed, which process the MNA is called commutation. The brief period during which coil remains short circuited is known as commutation period. When the plate of the armature coil crosses the magnetic neutral axis, the current direction in the coil reverses. The coil which is undergoing commutation will have self-induced EMF L dI by dt by Lenz's law. The self-induced will try to oppose the cause. In the present case, the change of current is the cause, so the self-induced EMF in the coil which is undergoing commutation will not allow the current changes quickly, and hence the sparking will occur in the commutator. This voltage is called reactance voltage. Armature reaction problem and the commutation problem may be overcome by providing compensating winding in the poles and by providing interpoles, also called compoles, respectively. Diagram shown in figure. Compoles and compensating winding is in this diagram shown in figure. Circuit diagram is compensating winding in series with generator. From the figure, it is clear that the magnetic field produced by the compensating winding will act in such a way that the armature reaction effect is neutralized to a large extent. Interpole or compole. The interpole serves the purpose of producing a rotational EMF in the armature coil. which is crossing the magnetic neutral axis. MNE is rotational EMF will try to nullify the reactance EMF, self-induced EMF. In this way, the computational problem is solved to a large extent. These additional features are and must, especially for a machine of large capacitor. Electrical machinery 1 DC generator 2 marks, hence question and answer. 2 mark questions for hinge. Cross magnetizing and armature reaction. Compensating winding neutralize the cross magnetizing and armature reaction. Absence of compensating winding, the flux will suddenly shifting backward and forward with every change in the load. All strike using mica sheets in commutator. Compensating windings are connected series with the armature. Compensating windings connected series. Current flow opposite direction in armature conductor below the pole shoes. Armature number of armature amperes per pole for compensating winding is equal to 0.7 into armature amperes turns per pole. Commutation. Converse currents AC to DC, mechanical rectification, that is, this process by which current in the short circuited armature coil is reversed, which is crosses the MNA, is called commutation. Commutation period, short circuited period, that is called compoles, that is called interpoles. Commutation problem may be overcome by providing interpoles. Compensating winding in the poles by providing interpole compoles. Compensating winding series connector. That is in for 2 more questions and answers. Thank you.